Good afternoon. A report is presented on the topic application of paragraph vectors model for semantic text analysis. Authors Gruzdo, Kyrychenko, Tereshchenko, and Cherednichenko. At the present stage of the development of information technologies, both around the world and in Ukraine, the task associated with the processing of textual information for solving a number of tasks, such as detecting plagiarism, recognizing text, highlighting structural blocks of text, analyzing and issuing advisory tips, are of particular relevance. In particular, special attention is given to determining the meaning of text documents. When determining the meaning of text documents today, there are two large areas that are trying to solve the problems associated with the semantic perception of text blocks, namely the construction of ontology-driven information structures and determining the meaning of the text using semantic analysis. Although many works have been devoted to solving this problem, which have been developing for more than half a century in both directions, but the most successful in world practice is the direction associated with semantic analysis of the text. As a result of the foregoing, the task of creating effective information tools for determining the meaning of text documents and, as a consequence, expanding the functions of determining authorship and identifying textual borrowings is irrelevant. A meaningful statement of the research problem is presented on this slide. Under the semantic analysis of the text, when studying the issue of determining the meaning of the text, we will understand the component assessment of the number of words or phrases that determine the main meaning of the text, and statistical indicators inherent in text of various types. Taking into account the functions and style of language and speech, 6 main functional style types of text are spoken text, official business text, socially informative text, scientific text, literary text, religious works. The semantic of text of different functional style types are different in different parts, but at the same time, depending on the type of text itself, it helps to understand the essence of the text and determine the meaning depending on its specific interpretation within the framework of a particular orientation of functional style texts. On slides 5 and 6, fragments of semantics are presented, which demonstrate the historical aspect of solving the problem of semantic analysis of the text. It should be noted that although there are a lot of works and problems to be solved within the framework of them, the problem of determining the semantics of the text, although it has been solved for more than 60 years, it is still not solved. During the analysis of the primary sources of the first works devoted to semantic analysis, there was a tendency to divide the work into those that consider solving abstract theoretical problems and those that are aimed at facilitating work with the computer and software implementation of solutions. It should be noted that all approaches and models described in them are aimed at solving a specific problem and therefore can only be applied to a narrow circle of subject areas. The mathematical apparatus is also suitable only for the formalization of certain linguistic mechanisms. Also, all this gives rise to the need to develop a solution in which there will not be a partial loss of the meaning of the text, thus increasing the percentage of correct decisions and correlations of results in the process of semantic analysis of texts. Slide 8 shows functional style types of text according to the classification of Vinogradov, which are aimed at facilitating the process of automatically determining the type of text, which in turn allows you to automatically select more appropriate algorithms for analyzing text, depending on the type of work. The classical semantic model consists of the word itself, its definition, examples of combining it with others, and composing phrases, sentences. But in its classical form, it is very difficult to use, since it requires significant computational resources on large volumes of text. In turn, this imposes a number of restrictions on its use in various fields, since some applications are not allowed to access the Internet from a security point of view, and the mainframe is a very expensive pleasure for the average user. That is why the existing solutions for semantic analysis are diverse and their application depends on the application area of the problem being solved. A generalized sequence of semantic analysis of the text is shown on slide 10. Given the specifics of documents and depending on the types of textual words, there are various interpretations of the process of semantic analysis. During the study, an analysis was carried out and the general sequence of semantic analysis of the text is described on slide 11. Before talking about private methods of extracting semantics from texts, I would like to emphasize that in computer linguistics there is a situation where the algorithmization of a certain methodology inevitably goes in different directions. Some of the most popular of them are shown on slide 12. The most significant and well proven is the model of paragraph vectors, because it has high accuracy of decisions and results in the process of determining the semantic component of the analyzed text. Slide 13 shows the pluses of the paragraph vector model. This model, while determining the meaning of text documents, adds a memory vector to the standard language model aimed at determining the theme of the document. This model allows you to work with documents of different lengths, such as fragments of text, sentences, paragraphs, and documents. That is why this model was chosen for analysis, since it is it that allows you to determine borrowings and analogues depending on the structural elements of the text, and also satisfies the task of the search by keywords, by annotation, and by articles with different sizes. The model of paragraph vectors in the classical form allows us to solve the problem of predicting a word given in other words in the context of the analyzed text. In the context, each word is displayed as a unique vector represented by a column in the matrix. The column is indexed by the position of the word in the dictionary. The concatenation of some of vectors is subsequently used as features for predicting the next word in sentence. It can be seen from the figure that the paragraph vector is concatenated or averaged using local contextual word vectors to predict the next word. The prediction task changes the word vectors and paragraph vectors. It should be noted that the classical model does not fully allow to implement software calculations and verify in practice, as well as draw reasonable conclusions about the applicability for the task of finding the similarity of documents. Also, in the classical form, in the model of paragraph vectors with a large amount of data, an increase in the size of the body is observed. Therefore, the dimension of the vectors which will lead to high computational complexity. Therefore, it is necessary to consider this model in more detail and describe the work in the form of an algorithm. To do this, you need to understand what methods are at its core. Early in the work, the study of semantic analysis libraries in various programming languages such as Java, Ruby, C#, and Python was performed. Among the large list of libraries, the Python Gensim package was highlighted as it is one of the most powerful and optimized packages for building semantic text models. Based on the foregoing, it should be noted that the paragraph vector model is two methods, distributed memory and distributed Bag-ofWords. The DM method predicts a word from known previous words and a paragraph vector. DBOW predicts random word groups in a paragraph based only on the paragraph vector. These methods are fully implemented in Python and are represented by the word2vec and doc2vec algorithms in the Gensim library. The word2vec algorithm is shown on slide 17. As you can see, a dictionary is created first, and then a vector representation of the words is calculated. The vector representation is based on contextual proximity, the essence of which is that words that appear in the text next to identical words will have close coordinates of the vectors, words, which in turn allows us to more accurately determine the semantic component of the analyzed text. Word2vec includes the algorithms on slide 18. CBOW and skipgram are neural networks architectures that describe how a neural network learns from data and remembers word representations. They have different operating principles. CBOW predicts a word in a given context, and skipgram allows you to predict the context of a given word. The continuous Bag-ofWords algorithm is shown in more detail on slide 19. It should be noted that CBOW uses the same matrix which receives several input vectors representing different context words. Learning is done using a simple neural network using a passage through the entire collection. Input, one hot word representation. Exit, distribution on the words of the collection. Slide 20 shows a neural network for the skipgram algorithm. The neural network in skipgram is two-layered. The second layer implements hierarchical softmax. The fundamental difference from the CBOW model is that the word VT is predicted as many times as there are words in its context, and each time is predicted based on only one of the context words. According to the authors of the algorithm, training on the skipgram model is more expensive, but usually gives better results. The second method of the paragraph vector model is distributed Bag-ofWords. It is a set of algorithms that allow you to get distributed vectors for parts of text. Text can be of variable lengths, from sentence to large document. Doc2Vec allows you to work simultaneously with words and text on the document. This fact is very useful in solving the problem of finding the similarity of documents as a subtask of finding plagiarism. A graphical interpretation of the distributed memory method included in the distributed Bag-ofWords is shown on slide 22. As can be seen from the figure in distributed memory, each document is represented by a unique vector in the form of a column in the matrix, and each term is represented by a unique vector in the form of a column in the matrix. The document vector and the word vectors in it are combined or averaged to predict the next word from the context. In distributed memory, tokens can be considered as separate words. They act as a memory that remembers what is missing in the current context or theme of the document. Slide 23 shows a graphic interpretation of the distributed Bag-ofWords. Distributed Bag-ofWords is simpler than DM. It ignores the word order, and due to this, the learning phase is faster. DBOW uses ignoring words from the input context, but it is necessary to predict randomly selected words for the output document. At each iteration of the stochastic gradient descent, a text box is scanned, then a random word is scanned in the text box, and a classification task is formed taking into account the document vector. Since Doc2Vec works more efficiently as part of longer messages, it was it who was chosen to conduct the experiment. A meaningful statement of the problem of the experiment is presented on slide 24. During the experiment, a number of intermediate results were obtained for texts of various subjects, and depending on the size of textual information, a summary table containing the average processing type of text fragments of different lengths of the models under consideration is shown on slide 25. So far, we can conclude that the use of the paragraph vector methods for semantic text analysis as a subtask aimed at solving text processing problems when plagiarism is detected, as well as text recognition, is advisable. With this in mind, we can make the assumption that the additional time that will be allocated for semantic word processing will not greatly affect the overall process of word processing. In view of the foregoing, we can conclude that when analyzing various types of work that differ in the volume, the time spent on semantic processing of texts will be approximately the same. This in turn allows, without significant time costs when determining the meaning of text documents, to add additional steps related to semantics, and thereby increase the accuracy of the results. Slide 27 shows the model for selecting text types from the database on a given topic, taking into account improvements in the methods of searching for borrowings in the text. The results allow us to conclude that it is not important for frequency highlighting which words were actually used, special terms or ordinary ones. The fact of their use is important. Statistical analysis does not reflect the intricacies of the impression of thought by the author. On the contrary, it uses the fact of template expression, allowing you to build a basic framework for further analysis. It allows the analysis of the context of terms with the subsequent replacement of elementary terms by characteristic groups, which requires considerable time, which can be reduced by analyzing the context of only the most significant terms, and using the results of the analysis to recalculate the weights, refusing to enlarge the terms. The results obtained in the course of the study will allow us to continue working on the task of analyzing texts for the presence of text borrowings and borrowing ideas, as well as in determining the authorship of a text taking into account its rephrasing. Moreover, it will be possible to further study and develop the concept of determining the meaning of text documents, as well as determining the semantic component of the analyzed text, which plays as a fundamental role in solving the problem of semantic analysis of the text. The results can be used in word processing systems. Thank you for your attention. The report is over.